So this video addresses how we're going to locate a point on a segment or on a tilted segment in the coordinate plane using the concept of weighted averages. So what exactly is a weighted average? I could give you several examples, but here are just two illustrations. So an illustration is kind of like a real world example of when you might use weighted averages. The first one might be finding an average in some of your classes. I actually don't average this way in our class, but some teachers weight things. So maybe tests are, say, 60% of a grade in a class, and let's say that quizzes are 30%, and then maybe homework would make up the remaining 10%. So let's say your test average was a 73, and that's 60% of your average, so you'd multiply by that in decimal form. And maybe you had a quiz average of a 91, and that would be 30% of your average, and maybe your homework average was a 96, and that's 10% of your average. Then you would divide that by the total sum of those percentages. And that's how you would come up with your average, or in other words, that totals 100%. Technically, we wouldn't divide in this case, but I could set this up so that we would divide to find it. But my point is that the tests have a heavier value than the quizzes and the homework. So there's a weighting to the sum of these things. Or maybe you just want to picture it like this, which is also quite similar. Maybe that you had a list of numbers, a set of data, and in that set you had 1, 2, 3, 4, 5, 6, 7 threes, and there were 2 4s, and there's only 1 5. But if we tried to show that on a number line, we just have a 3, a 4, a 5, but I've got 7 of those and 2 of those and only 1 of those. So you can see that the threes are going to have more of an impact when we do this straight up average of these numbers. In fact, there are 7 of the threes, 7 times 3. There are 2 of the 4s, 2 times 4, and there's only 1 5, 1 times 5. And you know when you average that you're going to divide by the total number of values that you had. And if you add 7, 2, and 1, we would be dividing by 10. We're dividing by the sum of those 3 numbers to come up with our weighted average. And it shouldn't be any surprise that if we do the math here, we end up with 3.4. And the average of these 3 numbers would end up right about here, way closer to 3, which makes sense because 3 had the greatest weight or the greatest impact on that average. So let's go ahead and just jump into the formula, and we'll use it with the types of problems that we've been doing, our ratio problems or partitioning a line segment. So the weighted average formula, which does look worse than it is, so this is going to be when we do it on a number line. Is this the weight of the first coordinate, so how many 3s I had, times the value of the first coordinate. The first coordinate was 3, plus the weight of the second coordinate. In this case, there were 2 4s, times the value of the second coordinate, plus the weight, there was only 1 5, the weight of the third coordinate times the value of the third coordinate, and so on. I can keep doing that, and there may only be 2 values that we're going to average together. We can go as long as we need to, and you're going to divide by, remember the 10 in this example came from adding 7, 2, and 1. You're going to divide by the sum of the weights of the points. And again, as many points as you have, you can keep dividing by that. So this is going to be our weighted average formula on a number line. So let's do an example of what that looks like. Okay, so here's a number line. Let's start with that so we have a visual. Okay, A is going to be sitting at -2. B will be sitting at +2. There's our visual. Here's the question. Here's what we know. And this is what the wording's going to be like on these problems. B weighs 3 times as much as A. Okay, that's what we know. And we want to find the weighted average and we'll go ahead and just call that P. So I'm going to use the weighted average formula. So think of it this way, B has more influence. P is definitely going to be placed between those two numbers, but since B weighs more, it's going to have a greater influence on P. So we expect P to be closer to B when we're finished than it is to A. All right, so let's start with the first value. We can go with the one mentioned first or the one that comes first visually. It doesn't matter. I'll just do it this way. What do we know about B? We know it has a weight of 3. So the weight of B is 3. The value of B is 2. To that, I've got another point on the number line that's been mentioned in this problem. So in this problem, I'm only dealing with B and A. Now, they didn't give us a weight of A, and anytime you don't have a weight, if a weight is not given, the weight is 1 if not given. Okay, because every value has a weight. So the weight of A is 1 times the value of A, and then we're going to divide that by the sum of the weights. B had a weight of 3, A had a weight of 1. So we'll divide by 3 plus 1. Okay, so we end up with, remember, the last thing we're going to do is divide. So in the numerator, we have 6 and -2. 6 plus -2. In the denominator, we have 4. The last thing we're going to do is divide. 6 plus -2, 4 over 4. We end up with 1 for the value of P. So in this problem, this is our answer. And here is where P is located. And as I mentioned, notice that it's quite a bit closer to B than it is to A. All right, let's do 2 more examples, a few more examples than I would normally do. I want to show you that sometimes you can have more than 2 points. So we've got, so here's 0. Okay, so C, I just wrote the even values, but C is going to be located out here at 7. B is located at 2, and A is going to be sitting at 0. So here's our number line, and then here's our problem. Here's what we're looking for. We want to find P, and once again, P is the weighted average if A weighs 5 times as much as C, and B weighs twice as much as C. So notice both of those values, A and B, were compared to C, okay? So A has a weight of 5, and B's weight is twice that of C. B has a weight of 2. That means that by default, our C is going to be the value with the weight of 1. Okay, so C is going to have a weight of 1. So here we go. What do we know about A? Its weight is 5. So it's 5 times, and the value of A is 0, plus B is twice as much as C, so it has a weight of 2, and the value of B is 2. And then there was no weight given for C, so C has the weight of 1, and the value of C is 7. And we're going to divide that by the sum of those weights. So remember, we had a weight of 5, a weight of 2, and C had the weight of 1. So we'll divide by 5 plus 2 plus 1. If you always write your weight first, then you can see the numbers that you should be adding in the denominator. Okay, the last thing we'll do is divide. 5 times 0 is 0, plus 4 plus 7, and in the denominator, 5 plus 2 plus 1, we have 8. So we end up with 11 divided by 8, and 11 divided by 8 is 1.375. So when you have a few numbers on the number line, it's a little harder to picture exactly where the P, the weighted average, is going to end up falling. But notice that it has to be in between these numbers somewhere. And it does make sense that it ends up down here closer to the A and the B, since A and B were stronger than C. So their influence or pull on that value is going to be greatest. Okay, I just want to do one quick example of how to use the weighted average formula when we do ratios. And you can take it or leave this, because remember, we already have a formula for ratios. So suppose that segment AB is going to be split up, is split such that AC to CB is 3 to 7. Okay? All right. And I'm just doing this very quickly, so I have no idea if this will work out very nicely. Let's just go ahead and put those values at 1 and 5. So A is at 1 and B is at 5. So remember what this means. It means between A and C, there will be 3 parts, and between C and B, there will be 7 parts. So on my segment visually without, the numbers, here's A, B. If there are only 3 equal parts between A and C and 7 between C and B, I know that C is going to be closer to A. That means that A has a greater pull on the C, so A is the strongest. And this is exactly how our ratio formula works. Remember that the second number in the ratio gets multiplied by the first coordinate. And since A is the strongest, it makes sense that I would be multiplying it by the bigger number in this case. So we would just do 1 times the 7. Excuse me, I did that backwards. I want to be consistent. The weight, which is 7, times the value, which is 1, plus, so that means that the weight of B, it's going to get the smaller value, 3 times the value of B, divided by the sum of the weights. And the weights were 3 and 7. Okay? So we end up with 7 plus 3 times 5, 15 over 10. The last thing we do is divide. 22 over 10 will give us 2.2. And 2.2 would end up right about here. And notice that is indeed closer to A than it is to B. And so this would be P, our weighted average in that case.